This is Module 1, Lesson 11. We're going to review first, then we're going to try some word problems. Okay, the first thing here says, the table shows the 2013 salaries for 4 New York Knicks players. Order the players from highest to lowest. What we're going to look at is we're going to look first at their exponents. Which one has the higher one? Well, here's 7 and here's 7. Those two are the biggest. Okay, times 10 to the 7. Would be biggest. What would be bigger from there? 2.139 or 1.41? This one would be, wouldn't it? Okay, so here's the one, that's your top one. And let's actually move that decimal so we can see what that means. We're moving it 7 places. 2. We start at 2. 1, 2, 3, 4, 5, 6, 7. See? We've moved it 1, 2, 3, 4, 5, 6, 7. This player is making, let's see, high salary to lowest salary, $21 million, right? Okay. Let's see, have we done that right? 1, 2, 3, whoops, no. 1, 2, 3, 4, 5, 6, 7. Yes, we did it right. Okay. And let's do this one. 1, let's see. Okay. How many places are we moving? 1, 2, let's look at it. 1, 2, 3, 4, 5, 6, 7. We moved it 1, 2, 3, 4, 5, 6, 7 places. And this guy's salary is $14 million. So here's the high salary, right? Let's look at these two. Okay, these would be below that. So here's 1 and 2. This is 10 to the 6th, so it's going to be below 10 to the 7th. Look at your exponents. Which is bigger, 1.7 or 1.197? The 1.7 would be bigger there. The 1.197 is smaller. Let's see what their salaries would be. Okay, I'm going to bring his over here. 1, and then we move it 6 places. 1, 2, 3, 4, 5, 6. Okay. He is $1,700,000. Let's see about this guy. 1, 2, 3, 4, 5, 6. He is $1,197,000. So that's the lowest paid, right? You can work them out this way, or you can look at the exponents. The bigger exponents are bigger numbers. The smaller exponents are smaller numbers. And then we look at what's in front, right? Okay. Circle the lower number. Well, is 10 to the negative 8 smaller than 10 to the negative 5th? Yes, because negative 8 is smaller than negative 5. If you were to do this out, let's just see what you would get. You'd be moving it 8 places. 1, 2, 3, 4, 5, 6, 7, 8. You were talking about having 1, 2, 3, 4, 5, 6, 7, 8 places in front of that. Let's do this one. 1.2 times 10 to the negative 5th. 1.2, and remember, to make it smaller, we go left, right? 1, 2, 3, 4, 5. Okay, I'm going to write these out. I've got 4 zeros behind that thing. 1, 2, 3, 4 zeros there. 1, 2. Okay, it's obvious that this one here is a smaller number because it's got a lot more zeros in front of it, right? Write the following numbers in scientific notation. 6.2. Okay, how many places am I moving this understood decimal? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Times 10 to the 10th power. And it is positive because this is a bigger number than 1. This number is smaller than 1. I've moved the decimal 1, 2, 3, 4, 5, 6 places. 4.4 times 10 to the negative 6. The exponent's negative because the number is less than 1. And remember, our front number always has to be a digit between that's greater than or equal to 1 and less than 10. Okay. They want me to multiply these. We know if we multiply, we collect our like terms. 2.2 times 4, 10 to the negative 4th, times 10 to the negative 3rd. 2.2 times 4 gives me 8.8. So I'm going to substitute 8.8 in place of that. And when I'm multiplying these same bases, I just add the exponents. -4 plus -3 gives me -7 times 10 to the -7. Let's try these here. If you're multiplying these, you collect your front terms. 3 times 8, 10 to the third times 10 to the third. Okay, when you're multiplying these guys, you're having to work with the exponents. You're not trying to get them the same. That's adding and subtracting when you get them the same. 8 times 3 is 24. And this is times 10 to the, if I'm multiplying here, I add the exponents. Okay? And they want it in scientific notation. I'd need to move this one place. That's 2.4. Lars tells me that if I am going left, I add to this. That's 2.4 times 10 to the, and I went one place left. 6 plus 1 is 7. Okay. What if I divide these? Okay. Let's collect like terms. 8 divided by 4 over 10 to the 6 times 10 to the 6 over 10 to the 4th. 8 divided by 4 is 2. I've collected my like terms. 2 times 10 to the, and when I divide, I subtract the exponent. 6 minus 4 is 2. How about this one? Collect our like terms. 6 divided by 2 over 10 to the 9th divided by 10 to the 5th. 6 divided by 2 is 3 times 10 to the, when I divide, I subtract my exponents, times 10 to the 4th. Okay, that reviews what we've done before. Now let's look at some adding, subtracting, multiplying, dividing word problems. Each of the following problems involves using one of the 4 operations: addition, subtraction, multiplication, division. Solve each problem. Give your answer in both scientific notation and standard form. A corporation earned a profit of 2.5 times 10 to the 4th for 1 times 10 to the 3 days in a row. How was their total? What was their total profit? Okay, you'd think total would be adding, but we're adding this up for 1 times 10 to the 3rd days. So I can multiply these two. 2.5 times 10 to the 4th times 1 times 10 to the 3rd. Collect our front numbers. 2.5 times 1. Collect the back ones. 10 to the 4th times 10 to the 3rd. 2.5 times 1 is 2.5 times 10 to the, and whenever you're multiplying, you add your exponents. 4.3 is 7, okay? Now, if I were to do this in, okay, it's 2.5 times 10 to the 7th dollars. Let's do this in standard form. 2.5, we're moving it 7 places because it's a big number. It's a positive exponent, so we go this way. 1, 2, 3, 4, 5, 6, 7, okay? Now, that is $25 million, okay? Let's look at number 2. In 2013, the Los Angeles Dodgers opening day payroll was about 2.16 times 10 to the 8th, and the Houston Astros opening day payroll was about 2.4 times 10 to the 7th. How much higher was the Dodgers payroll? How much higher? That means we're subtracting, right? So we got 2.16 times 10 to the 8th. And we need to subtract from that 2.4 times 10 to the 7th. If we add or subtract, we have to have the same exponent. We have to be adding or subtracting apples and apples. Let's take the smaller one and convert it. 2.4 times 10 to the 7th. And I want that to be in something times 10 to the 8th because I want these to match, okay? When I'm trying to get it from 10 to 10 to the 8th, I'm going from 7 to 8. What am I doing? I'm adding 1. Laura says if I add, I go left, okay? So I move the decimal one place this way. 0.24, 0.24 times 10 to the 8th. So let's rewrite this. 2.16 times 10 to the 8th minus 0.24 times 10 to the 8th. And we subtract. 6 minus 4 is 2. I can't subtract 2 from 1, but I can borrow 1 here, and that's 11. 11 minus 2 is 9. 1.92 times 10 to the 8th. Now, that's in dollars. Let's see what that would actually be if I move the decimal 8 places. 1.9, 1, 2, 3, 4, 5, 6, 7, 8. That's $192 million. A TV show had 3.5 times 10 to the 6th viewers for the first episode. Let's see, is that 6 or 8? Yeah, that's 6. And 8.5 times 10 to the 6th viewers for the second episode. How many viewers do they have overall? Okay, well, if those two are the same exponent, then we don't have to change anything, do we? 3.5 times 10 to the 6th plus 8.5 times 10 to the 6th. Both of those are 6. If the exponents are the same, all I have to do is add these two numbers. 5 plus 5 is 10. That's 9, 10, 11, 12. 12 times 10 to the 6th. Okay, now that wouldn't be in scientific notation, would it? I need to move it one place. 1.2 times 10 to the, if I'm moving it one place left, Lars says that I would add an exponent to it, add 1 to the exponent. 1.2 to the 7th. If we move that decimal 7 places, 1, 2, 3, 4, 5, 6, 7. That is 12 million more viewers, or 12 million total viewers. And then let's look at number 4. The population of crowded town is 4 times 10 to the 6th, and the population of empty village is 8 times 10 to the 3rd. How many times greater? When it says how many times greater, remember guys, we're talking about the big, heavy guy. How many times bigger is he than his skinny little friend? And we talked about if you do that, if this one's 200 pounds and this one's 100, you would divide that to see how many times greater it was. And this one's 2 times that size or twice that size. Well, whenever it says how many times greater, you divide. And they're talking about the population of crowded town and empty village. How many times greater? This one's bigger. It's got 10 to the 6th. That one's 10 to the 3rd. I'm going to work this over here so we've got a little room. Let's see. 4 times 10 to the 6th divided by 8 times 10 to the 3rd. Okay, we divide that or into pieces, or we separate into pieces. 4 divided by 8 times 10 to the 6th over 10 to the 3rd. 4 divided by 8 is 0.5, 0.5 times 10 to the, and if I'm dividing, I subtract the exponents, 10 to the 3rd. Okay, now let's express this in scientific notation. I need to move the decimal one place this way. Lars says if I move right, I subtract 1. I'm going 1, so I would be 5 times 10 to the 3 minus 1 is 2. Okay. Now, if I do that in standard form, our decimal's understood to be here. We move it 2 decimal places, and I wind up with 500. Okay. Now I want to do, okay, that's the end of this particular lesson. Okay.